In the next 20 minutes, I'm going to do a little live coding, help develop some of the basics for a very, very simple platformer, following design recipes, etc., etc. I have my frame rate set down about 20 frames a second, so if it looks a little choppy, it may well be that that's just the frame rate. So here we go. Let's throw something up on the screen. Require. Oops, can't do that. We're in intermediate. Okay. We're gonna get a little, let's give ourselves a red rectangle. 30 solid. Okay, let's give that a run. Hello, hello. Man. Okay, we'll run a little slower. Hey, we got a red rectangle. Okay. Let's put it in a scene. Empty scene. Actually, make it a little bigger. Derp. Let's put it up there in the corner. Okay, yeah, it's actually centered on those coordinates. Okay, that's good. So, okay, great. There's our red rectangle. It's in the middle. Let's say that it's going to move. Maybe it's going to have a state of whether it's moving or not. Okay, so first of all, let's just have a state of the world be the position of the red rectangle horizontally. A world is a number representing a horizontal position. Let's draw the world. It's got to be world arrow image. Draw world W. Check expect draw world of 30 is going to be place image. Let's see. This guy can be our player. And world width is going to be 500. Fine. Place image of player on, oops, sorry, we were building a test case. Silly us. There we were right there. Place image of player at, let's say, this is going to be 30, and we'll just slap that guy about halfway down the screen on top of empty scene. World with world height. Okay. Okay, definitely the place that will not work yet. Good. But having done the check expect, now we got to do is drop this guy up here and replace the horizontal with W, and it passes. Okay. Okay, let's put together a simple onTick that just moves it to the right. Actually, let's actually let's add to the world whether it's moving left or right. A movement is left is one of left. Still or right. Okay, and now we're going to say a world is make world of number movement world. Let's say X posin and movement. Okay, now we gotta, this sublayer doesn't work anymore because our, we now have make world 30 left, and this guy is no longer just W as world X posin of W. This should still work. Yeah, okay, let's throw a big bang up in here and be happier. Big bang, initial to draw world. And let's define the initial world up here. It's just nicer. Define initial world. And we're going to start at make world 250 and still. Okay, and so let's just save this thing. Actually, you know what? I'm gonna, okay, so we're gonna go ahead and run this, and there's our guy. He's not moving, he's standing still. Excellent, test passed. We want some movement here. Update the world for passage of time. World arrow world on tick talk. Okay, so now we get some decisions to make. Talk takes in a world. Check expect talk of initial. Let's make a moving world. Moving. Maybe we only need this. Make world 250 left. If it's moving to the left, then maybe get back make world of 200. So now here we go. How far should he move? Base speed. Let's do this in pixels per second. Let's say maybe 100 pixels per second. Okay. Frame interval. 1/30th of a second. Make sure that gets in here. Frame interval. Okay, and now what we're going to say, time's running short, is we want to move the thing by how much? Times frame interval base speed. Okay, so that's one for yes. And maybe it's still moving left. Okay, so let's just haul this guy up here. The template gives us world X posin of W and world moving or movement of W. Basically, all we need to do here is not all, not all. Got a conditional here. String equal this guy left. Then we want to use this chunk here. And in particular, we want this thing to be this guy here. Okay, and let's do the same thing for right. And then for still, you're just gonna pop this guy out. Nothing changes there. Okay, oops, we still got those guys in there. That looks fine. Didn't need that, and the test's passed. We do not have a test of this guy. It was standing still, which was good. Let's have our initial world. Well, I think I'm okay with that. Okay, I think I don't need to see it move yet. Well, maybe I want to see it move. Do I want to make it see? Let's see if we can see how fast it moves. Okay. Okay. Yeah, it's okay. Boop, there it goes. Goodbye. Okay. Let's get some keyboard control over that. Okay. Handle a keyboard event. Define. Oops. This guy's gonna take a key world and a key event, and choose a new world. Key event handler. That's an approved thing to say. I think world and key event. And let's do a little check expect here. Okay, so I think what I want is for the when you're holding down the key for it to move, and then when you let go of it again for it to stop. So we can kind of, okay, let's just cheat on this. Well, okay, fine. So here's what we're gonna do. We're gonna say when the key is pressed, it goes into a moving state. When the key is lifted again, it comes off. And so let's do some check expects. World 250, still, if we hit the if we hit the left arrow, then it should look like it should be moving left. All right, okay. String equal KE left, then make world of world X W and left. Okay, so when we hit the and someone else, leave the world alone. All right, let's attach this guy down here. Well, first of all, let's see if it works. Test case passed. Actually, I think my movement isn't quite fast enough. I think I went about 150 pixels per second. On key H. Let's try this. Okay, great. It can move left and it can move right. Yes, excellent. Okay. Sorry, frame interval. Anyway. Okay. It's not really buttery smooth, is it? Ticking me off. All right, that's okay. I shouldn't have said that out loud, should I? Right. Okay, so now when we release the key, we want to... Oh, right. Yes, we got to have a separate key release handler. And a key release. Find key release handler. WKE. Same. And I think in this case, this is going to be a little interesting because when we let go of a key, okay, so what you'd think is when you let go of a key, it should stop. But actually, that's not always the case. It kind of depends on whether you're actually moving in that direction right now. So let's say, sorry. Make world 250 should still be exactly the same. Doesn't matter what key you release this, it'll still be still. But if you're moving left and you release the left key, you should then be no longer moving. Okay. Left, and yes. Okay. Okay, so this is going to be a little interesting. Yikes. So the basic thing here is, I'll tell you, if you release the key, which is the same as the direction you're moving, then you should stop moving. Otherwise, nothing happens. And string equal KE left string equal world movement of W left, then make world x pos W still. Okay, and the same thing if they're both right. Then we're going to start moving to the right. That didn't work at all. String, huh? Expects this. A string equal, huh? And let's fix that down here as well. Let's see if our test cases actually succeed now. Yes, they do. Got some lack of coverage here. Let's say you release the right key while you're moving left, then you'll still be moving left. Rats, didn't work. Okay, why did it not work? Okay, we have a nice test case there to check that. Oh, it's not tied in, is it? On key release KRH. Okay, let's try that. New on key. Okay, let's just look up on key. That's interesting. On key. On release. It's just called on release. Derp. On release. Okay. Okay, excellent. Like it. All right. So now let's do this up here. We can do something that allows us to move right. If someone hits the right key, then we should start moving right. Still not quite fast enough, I feel. I think we want to bump this up to maybe 200 per second. 300, let's just go. What the heck? Okay, feeling good. All right, it's time to start falling, I think. Maybe we need a floor. Let's see if we can get a floor going very quickly. Okay, so let's just make a hard floor for the moment. Next, up here, the physics is kind of up here. Is it? Interesting. Nah, it's right about here, isn't it? We're just going to put a hard floor at 200. And we're going to say, if you're above 200, you fall. Okay, well, before we do that, we're going to need a Y posin. And we're going to have to sort of start to graduate to, well, should we encapsulate both of those as a single thing? Yeah, probably so. Okay, we have posins, right? Over here, I think. Make posin. Yes, we do. Okay, great. All right, let's see what this looks like. So we're going to say 250, make posin 250, 250. Yeah, it is a bit of a... Should I just put the hard floor a little lower? Okay, hard floor a little lower. We'll put it at 250. Okay. Now, so the first thing we have to think about here is this guy has to be are we an intermediate, I hope? Local define pos to be world pos W, posin X, posin Y, pos, okay. Okay. Ooh, I got luck. Okay, those first two test cases should pass. There's no world x pause anymore. World pause W. Okay, so now suddenly we want to abstract over. We probably want to abstract over adding posins. Add two posins. Posin A and posin B. Make posin XA plus posin XB. Oops, I didn't make a test case. Y and Y. Check. Plus of make posin 4, make posin. That should give us make posin 27, 2802. 1 and 287, 291. Okay. This guy down here, move the player. We're going to want to abstract over that. Move world, posin, world. Check, expect, move player, make world, posin, 3, 2, 4, still. Posin. That should be a new make world where this guy is now 0 and 78 plus 4 is 82. Okay. Make world of posin plus world pause of W and P, and then world movements of P. Now we got that guy. Hopefully it works. Oh, nope. Taking away the test case. Okay. Okay, move player of W and make posin. Let's just put the okay. No motion in the Y direction. Okay, great. And this one is the same, except that it's positive. Okay. Okay, now don't change the names of fields. Okay, good. Okay, we got a couple of, yeah. Expected number given. Posin x of B, posin y plus, wait a minute, something silly here. Posin x, oh, plus, what happened there? That was bad. Right. Sorry. Good thing for the test cases. World movement. Qua. Okay. Oh, yeah. Make pausing. Okay. World movement. Okay, we're this should be a make pausing. From call expected. Okay. Oh, we got another same thing here. Yeah, same thing here. Okay. May world movement just should have been a W. Okay, our A tests pass. Our test coverage is not fantastic, but there it is. Okay, we got we've extended this so that okay, looks good. So the next thing to do is to think about we want to be able to, oh right, jumping, falling, yes. Okay, great. We had a floor, yes. And now let's do some falling. Simple physics is just you just accelerate downward. Okay. Acceleration in, okay, so now for vertical stuff, you're actually going to have to keep track of a velocity, basically. Okay, so probably the right thing to do here is to change the representation of the world so that it actually now has both, oh, I think this is right. I think you're going to want to have both an X and a Y and simply graduate to putting a posin in that guy as well. All right. Oh, what a pain. Oh, what a pain. Okay, make. Okay, so we're changing the representation of the movement. And probably just call this delta position for, you know, like dx, dy type of thing. Okay, it's a pain, I admit. So base speed. Oh, the question is, which of the units of this be? These should probably be pixels per frame. Yeah. Okay. So let's make this guy pixels per second. Make this guy actually pixels per frame times 300 frame per revolve. So the base speed is now in pixels per frame. Okay. All right. There's a whole bunch of stuff that's going to have to change now. In particular, drawing the world is going to be totally unaffected. Thank heaven. Okay. We have pause and plus. We have move player. Talk is actually going to get easier because this guy just becomes move player W world dpause of W. And so in fact, should we leave that in there or should we simplify it so it just updates it? Okay, I'm living in a world of optimism here. Don't want that. Pause and plus of world dpause of W, and here world dpause of W. So basically you have a simple velocity type of thing. So this guy is going to look a little different. In particular, this guy is going to go in here, and then this guy is going to look like that, except that this component will be right. This component will be right here. Right. And that stuff, boom, gone. Excellent. Okay. Make posin negative base speed and 0. And it'll be 250 minus base speed. And the 100 will stay the same. And this guy will look like that. Okay, that part looks okay. Now, key event handler. Right, so that's going to totally mess things up. This guy should make posin negative base speed. Okay, this is going to be, that's going to be wrong there. We've got to leave that thing alone. Posin X, posin Y of world dpos of W. Okay. Otherwise, leave it alone. Oh, how is that working? What? Oh my. Make posin. Okay, and if you hit the left key, then it should be like this. Except that this should be minus base speed. Let's do something different here. Okay, so we're not affecting that stuff. Let's see how we're doing here. World movement. Gotta change this guy. Oh, this is interesting because left. Okay. Posin X. Oh. If this other gets set to anything other than, maybe we should say less than 0. If it's moving to the left and you release the, things are getting interesting there. Okay. Yikes. Make posin of. We want to keep the X and Y axes independent here. It's getting a little more tricky. Okay, let's think. Okay, once we have walls, this is going to just break horribly. For now, though, it'll be fine. Won't work when we have bouncing off walls. Okay, make posin of 0 and posin Y of world dpos of W. Much easier to just keep this guy. Okay, if it's moving to the, you release the right key and you're moving to the right, then again, we're going to, yes, could even abstract over that. In fact, let's just replace still with make posin 0, 0. Like for my test cases, I think I'm going to use 4 here actually. Replace. Movement is not. That thing is gone. Okay, so now key release handler. If let's find left here is going to be make posin of negative base speed 3. And here's the left 2. You're still going to be moving to the left, right? Wait, I'm confused. move player, yeah. And let's take out the Big Bang for now. My disk is going to be full in moments. Okay. Is it a real bug? -10. 23. Where is that error? Where is... 23. No, not a real error. Okay, good. My tests pass, which means in principle at least, I'm good to go here. Let's try it. Okay. Yeah, I've got that working. All right, now let's do a little falling. Let's try to do some falling. Okay, so downward acceleration in pixels per frame. Define G. Okay, that's probably a lot more than 9.8. I'm probably going to want something like 100. No, maybe not. No, that would be pretty nuts, wouldn't it? Let's do 10. That's fine. I'll start with 10. Okay, so now we just need to adjust. If the thing is above the hard floor, then we need to make it fall downward. In fact, let's just make it fall first. Okay. Let's put that here. Increase. Accelerate downward. Okay, this is going to take in a world and return a world and find gravitate of W. Check, expect, gravitate, make world, make positive 3, 1, make positive 7, 98. So after doing that, the only difference is that it's going to be that the y component is increased by 10, 108. Okay, so let's take out the pieces of that, and basically we're just going to, it's like move player, we're just going to make world pos of W, and this one time I'm adding pos and plus of world dpos W and gravity, which is gravity vec. Let's just do it here. Define gravity vec to be positive 0 g. Okay. Let's see if that works. Okay, and it seems to. Okay. Oh, sorry, we haven't run the test cases yet. Yes, it passed. Okay, and so the next thing we have to do is apply it. Let's apply gravity before we, probably after we move the player. Gravitate. Okay, let's try that. Yeah, it's gone. Okay, right, now we need our floor. Really? Oh, right, because we have a test case that we just broke. Okay. This should be 10. Okay, hopefully that'll be correct. To make sure those tests pass. Yes, they do. Okay, now we need a floor. We have a hard floor at 250. Let's say that so first of all, gravity stops your downward motion if you're at the hard floor, and then furthermore, your posin itself gets reset, because we're going to change the gravity, and we're going to also, okay, so this is, I think this is actually two separate checks. So it has to do with the position. So when the position is this, then the Oh, this is one of those goofy things. When the position is, I have to go. Let's figure this out. Okay, so when the position is there or below, okay, so basically we kind of want to do a post check on this. Say after you've moved and applied gravity, then we have a wonk, like a reset, a possible reset, floor collision. I think we're going to make this a separate function. Halt downward motion when below floor. Find floor stop of W. I'm so short on time. I'm going to skip the test case. I know I shouldn't. Dear me. Less than when, sorry. Yeah, when hard floor is less than posin y of world pos W. That is to say, we're on the floor. We're below the floor. We're going to reset in both the, make world, make posin X changes world pos W and hard floor. Now we also have to arrest this guy. This guy changes to 0. World dpos and velocity changes to 0. Else W. Now let's put the floor stop in. Less than or equal to, and that's actually going to be important here. Okay, it should be possible now to fall to the floor if you start above the floor. Let's start at 200. Yes, you do fall to the floor. Let's actually try 0. And now, the last thing we want is some kind of, I don't have time for a jump. I have no time. Okay. Alas.